we said yesterday it could have two, what? Turning points, right? Okay, so if you graph this and it had two turning points, how many x-intercepts does that have?
4. 2. 3. What did I say?
3. Okay, if I said like x to the 4th minus x plus 5, how many turning points could that have?
3.
3 turning points. So there's 1 turning point, 2 turning points, 3 turning points. Now this is not the graph for it, I'm just drawing a graph with 3 turning points. How many x-intercepts does that have? 4. So this one had 3, this one had 4. How are those numbers related to the function? Yeah, that degree. Now, do they have to? We think about x squared. That means it could have 2 x-intercepts, right? But when we graph x squared, does it hit the x-axis 2 different times? No. So the number of x-intercepts is at most the degree. So the degree is how many zeros, how many solutions, how many x-intercepts it can have, but it could be fewer. So if it's an x to the 5th, at most, how many times could it touch the x-axis? 5. If I give you a graph that touches the x-axis 3 times, then the degree would have to be 3 or more, right? Okay, so next thing I want to touch on is multiplicity. We have seen multiplicities before, like when we were solving quadratics, we might get the same answer twice, and we said it was multiplicity of 2. Or when we factored things, we sometimes saw that happen. So multiplicity is just a repeated answer, and that actually impacts your graph. If the multiplicity is an odd number, the graph goes through the point. So if you have an x-intercept that has an odd multiplicity, your graph's just going to hit it and go through. But if that multiplicity is even, the graph will bounce. So if this had a multiplicity of like 2 or 4, what's going to happen is your graph will hit that and bounce back the same direction. So we can tell if we ever have an x-intercept where it reflected, or it hit it and just bounced back, then it had to have an even multiplicity. If it goes through the point, that multiplicity had to have been odd. So here's what we're going to do for a minute. You guys have that handout from yesterday. You did the first 12 questions, talking about the end behavior and the turning points. So then the last questions ask things about the graph. So first few are just which one of these is the graph. And you need to use things like end behavior. You need to use things like the number of zeros to look at this. So like 13. Which of them is the graph of x cubed minus 3x squared minus 6x plus 8? So first of all, what should the end behavior be? Down, up. So it might only be one option that works. But if there was more than one option, you would have to look, how many times could that one hit the x-axis? At most 3 times, so you can narrow it down. So I would like for you to take a few minutes and try those questions. If you would like to find a partner and discuss those, that would be wonderful. Let's do 2 to 3 people in a group, if you would, so you can talk through that with somebody, and then we will talk back as a class. So we are still talking about polynomials. We're going to continue on this graphing stuff, so all the things that we have been using, we will continue to use as we move on with this. What I need to talk about first is what is called the intermediate value theorem. This is not something we will use a lot, but we should talk about it. It does pop up occasionally on ACT and things, and it's a pretty simple theorem if you know what it is telling you. So what the intermediate value theorem says is in a polynomial, if, let's say, A and B are real numbers, and P of A and P of B have different signs, there is a number between A and B that makes the polynomial equals 0.
Kind of looks like a face.
Yeah. Okay, so that's kind of a wordy way to say it, but here's what it means. A and B, they're just two x values, so let's say this is A and this is B. And P of A and P of B, that's just meaning the y values at those points have different signs. So maybe A gives you a negative value and B gives you a positive value. Because we know polynomials are continuous curves, the only way you can get from a negative to a positive is by crossing 0. So if you go from a negative to a positive, that means there is some number that makes that polynomial equal 0. Okay, and that's all it's saying. This is a useful piece of information when you are trying to find a 0. If you were to plug in a couple numbers and one of them has a positive answer and the next one gives you a negative answer, then you know that somewhere in between it equals 0. For us, what we're going to do is a pretty simple type of calculation. We're just going to check to see if there's a 0 between two numbers by using this intermediate value theorem. So here is your example. Here's my polynomial, and I want to show it has a 0 between 2 and 3. So all we're going to do is plug those two x's into the equation. So we are going to find P of 2 and P of 3. Okay, you don't have to necessarily show me a lot of work. You're welcome to if you plug in a 2. I would just pick up my calculator probably and plug it in. So when you plug in a 2, what do we get out? Negative 1. Then we plug in a 3. What do we get? 7? Is that right? So what that means, you don't need to draw a picture, I'm just doing that to illustrate what happens. 2, negative 1 is the point on this graph. and 3, 7 is a point on the graph. Since we know it's continuous, the only way to get from a negative to a positive is to hit 0. So the sign changed. A 0 exists between 2 and 3. I don't know what it is, but I know some number between 2 and 3 would make that whole equation equal 0. Let's say I asked you to approximate that number. If I wanted you to use your calculator to find that. So grab a graphing calculator if you don't have one. And let's graph the original equation. We have x cubed minus 2x squared minus x plus 1. Okay, so I can see right here between 2 and 3 it does cross the axis. Your calculator can find that for you. If you go to second and then hit the trace button, that takes us into our calculate menu. What do you think it's called? A 0, number 2. Okay, you have to tell your calculator where to look. So it's going to ask you for a left bound and a right bound. A left bound is just to the left of this point, so somewhere before that point happened. Then it asks for a right bound, so you have to go past your point. You're telling your calculator, start looking here and stop looking there. And then it asks you for a guess. You don't really have to worry about that. We're close enough. Just hit enter. So it tells us it's about 2.24. So if I asked you to approximate that, I'm just asking you to use your calculator and get an idea of where that 0 is.
So let me grab mine.
Any other questions there? So here is my next question. If those things are the same sign, so if they don't change signs, if I have a positive and a positive, does that mean that it doesn't equal 0 between them? No. Why? Okay. So, for instance, if you take a parabola, if you plug in -1, you get 1, and positive 1 gives you 1. So those both are positive numbers, but doesn't your parabola hit 0 in between them? Yes. So if they're the same sign, it doesn't tell us anything. It might have hit 0, it might not. We just don't know. The only time we can make a conclusion is if the signs are different. Trying to decide how far to go, guys. What do you think?
I think this is good.
This is good, huh? So the next piece we're going to start talking about is synthetic division. I think I'm going to stop. I have time to introduce it, but if I start talking about it, I'm not going to have any time for you to practice anything. And then we have the weekend, so I'll probably just end up going over it again on Monday. So we're going to stop here. What I would like for you to do, there is a Math Excel assignment. If you look at it, it is not due until Tuesday because we're not done with this section, okay? It is a combination. Some of the stuff is like last night, so it's going to ask you end behavior, how many turning points, those kinds of things. I think there's 21 questions. You are ready to do 1,